Okay, students, hello again. I'm going to do another review with you on section 9.2. This time I'm going to use the study guide. Notice some vocabulary: coterminal, radian, sector, arc length, and area. Those are the key ones, though you're not going to have a vocabulary on the quiz. But you are going to have different parts on your next quiz, which is probably going to be on Tuesday. Okay, is your next quiz. Most of you did very well. I'm very proud of you. So you all did as well as you could, and even better than what you thought you could do, which I never doubted. So keep trusting yourself and doing your work. You're doing fine, and before you know it, we'll be back together. I'm not putting my face again on here because I scare you enough. So I just thought that I'd show you on this setup that I have here to teach you. So let's do some review. First, we're going to talk about drawing angles in standard position. And here are 3 examples that are in your study guide: A, B, and C, and those are your solutions. Notice it's positive going this way, negative going this way. Counterclockwise is positive, clockwise is negative. It goes this way, even though it goes more than once around, it's still positive. It just goes past 360. So this angle here would be just shorter than this angle, you see? Because this is negative 60. So it actually just go this way here, like this. So if I were to draw it on this graph, I can just do this and draw a line this way, and that would be negative 60 because it is going this way. 255, actually, we can do that on this graph paper. So I'm going to show you number 2, 255 degrees, right? And it is positive. So I would go, okay, I would go 90, 180. Remember, this is 270, so it's somewhere in here. And I'm just going to draw a line that way. And notice I draw my arrow, 255 degrees. Easy peasy. How about if we have 420? Well, 420 is positive, but remember, this is 360 degrees, okay? 360, this is 90, this is 180, this is 270. So in order to go 420, I've actually got to go all the way around. And how much more do I need? Another 60. So that goes somewhere in here. So I go like this. So I need 420, so I need another 60. So this is 420 degrees. Okay? Now let's do this example, negative 200. And that one looks kind of tricky, but it isn't. Just remember, now you're counting this way. So now you're counting 90, 180, 270 going this way because it's negative. So you've got to remember you go this direction. So I'm going to go 90, 180, and it's going to go right about here somewhere. So I'm just going to draw a line this way. Sorry, it's not straight, but you go like this because that's 180. It's a little past 180, negative 200 degrees. Okay? Now, how about if we wrote this in pi? Okay? And we would say that this one would be, let's say, 4/3 pi. Okay? Well, if you look at your graph, remember this is 0 or 2 pi, depending if you go all the way around. Pi over 2, pi, 3 pi over 2. Well, this is 1.3 approximately, right? 1.3 repeating. Okay? Let me bring that up so you can see it. See? 1.3 repeating. Well, this is 1.5, right? Well, and that's less. So that means that this is going to go this way and somewhere in here is going to be my line. And that's going to be 4/3 pi, or 4 pi over 3, because now you're counting and it's positive. If we're going negative, then that would be negative pi over 2, negative pi, negative 3 pi over 2, and so on, because then you're going in opposite directions. So don't let that scare you if it's positive or negative. Just remember your signals, whether it's degrees or in radians. And don't let that scare you. Okay, let's move on to the next thing. Now let's talk about converting between degrees and radians. And this should be very easy for most of you, because all you're really doing is, if you want to convert to degrees, you just got to multiply by pi over 180. But if I'm converting radians to degrees, I'm multiplying by 180 over pi. Well, how do you remember which is which? Well, if you want to have radians as an answer, it better have pi in it. And if you want degrees as an answer, the pi's have to cancel. So one has to be on top and one has to be on the bottom. And that's why you multiply by 180 over pi. Okay? So let's look at this one. Let's look at this, negative 150. Okay? So doesn't matter the direction here. All I'm doing there is I'm multiplying. I'm going from degree, it says degree measure to radians or radian. If you start out with degrees, you want to end up with radians, right? So here, I'm going to multiply by pi over 180, and I'm going to simplify, okay? So to simplify that, it's going to be negative still. Well, 3 goes into 15 and 18. So if I divide top and bottom by 3, I get negative 5 pi on top, and divide that by 3 is 6. So negative 5 pi over 6. Okay? So again, I started with degrees. I need radians, so I better have pi. Now let's go the other way. Let's do number 7. I need to convert that to degrees. Well, the pi's got to disappear. So I got to multiply by 180 over pi, so the pi's cancel. And now I'm going to simplify. You could multiply and then divide with a calculator, or you do what I do, is I just divide 6 into 180. That's 30. 30 times 5 is 150 degrees. Easy. Nothing to it, right? And of course, nothing to it. Let's do another one with pi, okay? This time I'm converting radians to degrees. So I'm multiplying by 180 divided by pi, which the pi's cancel. And now I know 4, divide 4 into 180. Isn't that 145? Now, if you don't remember, just do it on the calculator. Of course, you better turn on the calculator, clear it. You have 180 divided by 4 equals 45. Okay, now my answer is going to be negative. So this becomes 45 times 3 negative equals negative 135 degrees. Easy. So you should be able to do this with no problem. Okay? The last part of 9.2 was the arc length and the area of a sector. Well, if you're doing arc length, there's your formula. If you're doing area, there's your formula. But the key here is that it must be in radians. So that theta must be in radians, which means if it's not already in radians when they give it to you, you better convert it. Okay? For example, all of these questions give you degrees. So I better convert those to radians, or else I can't do the math. Okay? Now let's do, because I did one of these earlier, let's do number 10 together, right? So if I want the arc length, there's my arc length. So the first thing is S is equal to R times theta. Well, I need to convert that. Well, let's do that on the side. 240 times pi over 180. Okay, the zeros cancel. 6 goes into both of these. So I divide top and bottom by 6. Okay, and I have 4 pi over 3, right? Isn't that divide by 6 is 4, divide by 6 is 3. So now I know that that's 4 pi over 3 here, and I have my radius. Don't worry about the centimeters. So my arc length is going to be S equals 5 times 4 pi over 3, which equals 20 pi over 3. Don't go ahead any further, okay? You can, if it asks you for the answer, to leave it in this form, you can leave the answer this way, okay? But if you do the thing on your calculator, you can actually multiply 20, which unless it says to leave it in radians, you don't want to leave this in radians unless it tells you. If it doesn't, you do what I'm going to do right now. You're going to take 20 times pi equals divided by 3 equals. And I'm going to go to one or two places, 20.94. So this is 20.94, and we're talking centimeters. So we put centimeters. You don't have to worry about the centimeters, putting the centimeters as part of your answer. Just make sure you put this. And if it asks you for 10th, it's one place. If it's two places, it's to the second digit. If it doesn't say either one, try to go to two places. So there's your arc length. Now let's do the area. Well, the area is this formula. So the first thing I do is area equals 1/2 radius squared theta. Well, the theta in this example is the same. We just figured that out. I don't have to do it again. So I have to do 1/2 the radius. Please don't forget to square it. It must be squared. Times this in radians, 4 pi over 3. So that gives me 1/2 times 25 times 4 pi over 3. Okay, now you can simplify all this if you want, or not, because you have a calculator and asking you for an area. So you could just multiply all of this out. 25 times 4 is 100. 100 pi over, this is over 1, over 6. Now I need my calculator, right? So I'm going to show you my calculator so I can get my final answer. So now you could all do this all on the calculator. I just made it easy by multiplying 25 times 4. So I have 25 times 4, okay, pi over 6. But you can actually multiply all this and then divide, and it's still going to give you the answer. So here, I'm going to do 100 times pi equals divided by 6 equals. And again, I'm going to go to two places, but that's a 9. So that's going to be 52.36. Try to make sure you answer the question. Now, because this is area, it's going to be centimeters squared. Again, don't worry about the centimeters or the centimeters squared. You're going to be fine as is. If you don't have it, most of your questions doesn't matter what you have. Now, as far as your homework to prepare for your quiz on Tuesday, it's coming from this page that I'm displaying right here. I will post this on Google Classroom. It'll probably be, I don't know if it's going to be odd or even, or maybe a select group of questions. I have to decide that, but it's going to be from this page. You should be able to do it with no problem. I hope you're enjoying my videos. Please be safe, wash your hands, be careful, be safe, and hopefully I'll get to see you soon. Mr. Soto.